All right, today we're going to talk about part two of transformations of linear functions. And in part two, we're just going to talk about combinations of what we learned in part one. Um, if we're given the equation below, and we're looking at this first example, determine the change on the parent function f of x equals x. And the equation we're given is that g of x is equal to x minus 2 plus 4. All right, in order to complete this problem, notice that the x minus 2 plus 4 simplifies to truly just x plus 2. Okay, so we know that when x plus 2 is in parentheses, we say, okay, we know it's moving left 2 units. But when the parentheses is not there, and all we have is just our x plus 2, we say that it moves up 2 units. So, technically, these happen together. It goes left 2 units and up 2 units. And what I want you to do is use your graphing calculator to look at this now and compare it to this parent function here, the f of x equals x. All right, compare it. And if you don't have a graphing calculator, just go to Desmos.com to use the graphing calculator. Okay? So when you come over here to the examples, you're going to do the same thing that we did here in these examples. All right, x plus 6 minus 3 becomes x plus 3. Inside of the parentheses, this moves left 3 units. And then without the parentheses, it goes up 3 units. All right, now use your notes from yesterday to help you with 2, 3, and 4, and we'll talk about it in class tomorrow. All right, so the next one says, given the equation below, determine the change on the parent function, f of x equals x. And this time, we're given negative 3x. All right, that negative part says there's going to be a reflection. So we're going to say reflection. All right, and note that this reflection is across the x-axis, but inside the parentheses, it's about the y-axis as well. So we're just going to say reflection. All right, we're just going to put reflection, and we'll talk about the details of it later because it's actually doing both. We're just going to write reflection. That 3 being multiplied by our parent function is saying that there is going to be, compared to the parent function, it's more steep. So we're going to say here that it is more steep. Or we also call it a vertical stretch by 3. All right, you will also see that. But more steep is just fine to use. And we're done with the description of this transformation. So when we come over here to 5, 6, 7, and 8, we're going to describe what's happening here and use your notes to help you. All right, use your notes on part 1 to help you here. Remember, the negative says there's going to be a reflection, so we're just going to write reflection. And that 1/5 times the parent function of x means that there is going to be a graph that is less steep than the parent function. So we're just going to write less steep. All right, you may also see that it's called a vertical compression. All right, so just writing that out just in case you see it. All right. Now, I want you to complete 6, 7, and 8 and bring it to class tomorrow. Okay? In this next section, it says, given the equation below, determine the change on the parent function, f of x equals x. And we're given g of x equals 3 times the quantity, meaning inside of these parentheses, x minus 2. All right? Recognize that 3 is being multiplied inside here, and that 3 represents, like in the previous section, that the graph is going to be more steep than the parent function. So the first description we're going to write here is more steep. All right, also known as a vertical stretch. The x minus 2 inside the parentheses means we're going to go right 2 units. All right, it means we're going to go right 2 units. All right, so when we come over here to number 9, 10, 11, and 12, all right, particularly we're going to look at number 9. We're given g of x is equal to 3x plus 2. All right, and in relation to the parent function, that 3 times that x means that we're going to have a graph that is more steep by 3, or there's a vertical stretch by 3. All right, so that's what we're going to write here. More steep by 3, also known as a vertical stretch. All right, and that plus 2 is not inside parentheses, so we're going to say this goes up 2 units. All right, now I want you to take a stab at 10, 11, and 12. Always verify what I've said in your graphing calculator using Desmos.com. All right, let's go to the next section where we're given the equation below. Okay, it says determine the change on the parent function. So we're given negative 1/3 times x plus 3. So there's actually about 3 things happening here. That negative says there's going to be a reflection. So that's what we're going to write here, reflection. All right, the 1/3 says that the graph is going to be less steep than the parent function, also known as vertical compression. And the plus 3 inside the parentheses means we're going to be going left 3 units. Verify that in your calculator. All right, so when we come over here to 13, 14, 15, and 16, all right, let's look. Particularly, we're going to look at number 13. Remember, the negative represents reflection, so we just write that here. The 4 says we're going to have a graph that is more steep. And the 2 says we're going to translate right 2 units. And you complete 14, 15, 16. Last section. All right, we're given g of x equals negative 2 times x minus 4 plus 5. All right, doesn't that look interesting? So here, there's about 4 things happening. The negative means there's a reflection. The 2 means that the graph is more steep than the parent function by 2. The minus 4 inside the parentheses means we're going right 4 units. And the 5 means that we're going up 5. If we look here at 17, we have negative 1/3 times x plus 3 minus 1. The negative is reflection, remember. The 1/3 means that there is going to be a less steep graph. And the plus 3 means we're going left 3. The minus 1 on the outside of the parentheses means we're going down 1 unit. All right, guys. Complete 18, 19, and 20, and we'll review these in class. Have a great one.